This is for Year 11 method. It comes out of Chapter 2 to Section 13, question number 7. So we have y equals x squared plus ax plus 3. So a parabola that is a positive parabola and has a y-intercept of 3. And y equals 2x plus 4 are equations of two functions representing possible paths for forking tracks through a nature reserve. Okay, so I've entered these two equations over here in the graphing calculator. Y equals 2x plus 4 and y equals x squared plus ax plus 3. If a equals 1, find the point of intersection of the two functions. Okay then, so I'm going to come over here. If a equals 1, so given a equals 1, that will obviously make it x squared plus x plus 3. Open up simultaneous equations, take that, take this, solve it for x and y. And that tells me that the coordinate is a half minus root 5 on 2 and y equals 5 minus root 5. Write down an equation in terms of a for the situation where the straight line is a tangent to the parabola. Okay, so in part B, if x squared plus ax plus 3 equaled 2x plus 4, and if it is a tangent, therefore it touches once, therefore the discriminant would equal 0. So x squared plus a minus 2x plus 3 minus 1 minus 4 equals 0. Therefore x squared plus a minus 2x minus 1 equals 0. My discriminant would be b squared, so a minus 2 all squared, minus 4 times 1 times minus 1. And the discriminant equals a minus 2 squared plus 4. Now, for that to equal 0, a minus 2 squared plus 4 is not possible. Because if whatever this equals is squared, it will be positive, or it could be 0. Then you add 4 to it. It's not a possible situation. Hence, so here is the equation. That would be part B. Part C says, hence show that the line can never be a tangent. Well, it can never be a tangent because if I was to graph the discriminant against A, it's a positive parabola that has a turning point at 2 and 4, and looks like that. It can never equal 0. And since the discriminant can never equal 0, it can never be a tangent. Part D, find the turning point of the parabola and hence the value of y. Okay, the turning point's x coordinate will equal minus b over 2a. I have this as being my parabola, therefore b is a, which means in this particular case the x coordinate would be minus a on 2, and I need to find the y coordinate. So this is my expression for my expression for y equals. So I might just copy that, paste, and I'm going to make x equal minus b over 2a. So it's going to be equal to minus a divided by 2 times 1 or 2. So that's my y coordinate. So my coordinate should be minus a on 2, comma 3 minus a squared on 4. close bracket, and that's going to be the coordinate of the turning point. Using graphical features of the two functions, explain why y equals 2x plus 4 will never be a tangent to the curve. Okay. The graphical features of this particular situation is such. I've got a parabola that goes through at 3, and it's a cup. And I've got a straight line that goes through at 4. There is no way, no matter what my gradient of my straight line is, or what the features of my parabola, if it goes through at 3 and has a positive gradient, it must cut twice, and there's no way that it can be a tangent.